Hello, and welcome back to the Lion's Den. The popular creationist YouTube channel, Standing for Truth, I would personally consider it to be sort of the premier young Earth creationist channel on YouTube, posted a video in which he shares, for at least the third or fourth time, an oft-refuted response from PhD astrophysicist Jason Lisle as an attempted confusion of a rather brief claim made by Gutsick Gibbon in an interview with Seth Andrews concerning the distant Starlight problem. And again, Gutsick Gibbon merely mentioned the problem. She didn't say much more than that. And for those who do not know, the distant Starlight problem is an as yet unresolved problem for specifically young Earth creationists, in that we can detect starlight from billions of light years away, which seems to indicate that the universe is billions of years old, since we know that the speed of light takes time to go from some point to another point, like from a star to the Earth. And so if a star is 700 light years away, then we know that when we see it, we're seeing it as it was 700 years ago. In an attempt to overcome this problem, Standing for Truth posts a near 2-year-old interview he did with Dr. Jason Lisle, where he presents his anisotropic synchrony convention as an attempt to demonstrate some physical variance in the speed of light in order to overcome this distant starlight problem. Now, before I get into the fallacious reasoning which underlies the entire argument, I'd like to provide a direct response to the claims which Dr. Lisle makes in this video. Here we go.
How are we able to see stars and galaxies that are billions of light years away?
There's more than one way God could have done it. The method I think that he used doesn't involve any kind of supernatural activity at all. Of course, God can do miracles. That's not a problem for God. So we dare not say, well, I don't understand how you could have done that, God, therefore you didn't do it. Well, that's absurd. I mean, you'd have to eliminate the resurrection and turning water into wine and all these things. But the way that I think that God got the light here is I think that the Bible is using a synchrony convention that's different from our modern synchrony convention. Now, what's a synchrony convention? That's the idea that two clocks separated by distance are synchronized. Well, how do you decide if two clocks separated by distance are synchronized? Now, if the distance is short, it's pretty easy. You just look at them and you say, well, they're both synchronized. But if light takes some time to get from that clock to your eyes, then that might be a little bit of a problem. They might look synchronized, but in fact, one of them's a little bit of ahead of the other, but it took more time for light to get from one than the other. So you see, it becomes a little bit of an issue when the clocks become separated by cosmic distances.
So apparently, God gets the light to Earth. I guess light doesn't travel on its own? Also, the writers of the Bible had a synchrony convention for understanding what the speed of light was? You think people over 1,200 years ago had any idea about the speed of light, or that it even had a defined speed? And at this point, I should probably outline what a synchrony convention is. It's a way of describing the constancy of the speed of light, or whether it's even constant, based on a measurement of the physical travel time between 2 points. As a result of special relativity, two clocks which are moved away from each other will no longer be synchronized on minute scales. So this needs to be accounted for via a synchrony convention, a way of synchronizing the clock so that we can get accurate measurements. It's comparable to both inches or centimeters being a particular way, a convention, for measuring the length of an object. It's a way of characterizing the interval between two events in spacetime.
It turns out that there is no objective way to synchronize two clocks separated by a cosmic distance without assuming the speed of light in one direction. And when I mean the speed of light in one direction, most of the experiments that have been done to measure the speed of light involve either directly or indirectly a two-way trip. It's like you're taking light from a source, you're sending it out, bouncing it off a mirror and bringing it back, and you're measuring the total time, the total distance, and you divide the distance by the time. That gets the average velocity. And a lot of times people assume that it takes the light the same time to go that way as it does to go that way. We don't really know that. And in fact, according to Einstein, it's impossible to know that. People say, why would it be different in different directions? Well, I don't know, but there's no reason why it would have to be the same either.
Except that we do have reasons to presume its constancy through space-time. The thing is, Physically measuring the time it takes electromagnetic radiation, light, to travel some distance between 2 points in space isn't the only way to measure the speed of light. And it isn't the method through which James Clerk Maxwell derived the speed of light. The speed of light is generally given as c, the speed of light, is equal to the square root of 1 over epsilon naught mu naught, which means that it was mathematically derived, which results in a much more accurate measurement of c being equal to 2.99792,458 times 10 to the 8th meters per second, or 299,792,458 meters per second. Observations of the speed of light through measuring physical travel time do indeed comport very closely with this mathematical derivation via the Maxwell-Heaviside equations of electromagnetism. Moving even further down the historical timeline, Einstein, whom Dr. Lisle has himself already appealed to, meaning we can both agree on Einstein's authority here, showed that the speed of light is more a result of space-time and not electromagnetic radiation. It's the fastest speed any physical information can move, and in order to move at the speed of light, it must be massless. Gluons, the particles which carry strong interactions, the gauge boson of quantum chromodynamics, as the technical jargon says, is massless, and it also moves at the speed of light. The speed of light is a fundamental constant in the universe, present in many other fundamental parameters, such as the fine structure constant, which some would say is more fundamental than even the speed of light. So what this means is that the speed at which light, electromagnetic radiation, travels doesn't actually have anything to do with the radiation, or the direction in which it's traveling, or the distance between the 2 points which it's traveling. It has to do with space-time. And this further comports with the notion of it being constant through space-time. And going back to the equation, c equals the square root of 1 over epsilon naught mu naught. Epsilon naught and mu naught are two constants which give essentially the behavior of an electromagnetic field in the bare vacuum of space-time. Epsilon naught is the electric permittivity of the vacuum of space. It's the ability of the bare vacuum of space-time to permit an electric field through it. And mu naught is the magnetic permeability of the vacuum of space. It's the ability of a magnetic field to permeate through the bare vacuum of space-time. I just wanted to clarify that quickly.
It's what I call the anisotropic synchrony convention is the best method.
Here we see Dr. Lisle's anisotropy when he says anisotropic synchrony convention. The speed of light is anisotropic, not the same, in all directions, and he uses a different convention of synchrony with clocks to get a different measurement of the speed of light, one which is again anisotropic, moving infinitely from point A to point B, and then at half the speed of light from point B back to point A. The problem here is that this is like saying that one is going to measure a table in centimeters versus inches, because then the table will be longer because its length, the number of units which describes its length rather, will be greater in quantity as centimeters are slightly shorter than inches. Aha! You exclaim. By using a different convention, I have discovered that the length of the table is actually greater than it is when measured in inches, as there's more units describing its length. But this is obviously incorrect. As Dr. Lisle himself has already stated, the synchrony convention isn't objective, and this includes his synchrony convention. Changing the convention of measurement of a table isn't going to change the length of the table, and for the same reason, changing your synchrony convention when measuring the speed of light isn't going to change the actual speed of light. To posit so is, quite frankly, rather ridiculous.
It's consistent with the physics of Einstein. Nobody can disprove it. It makes sense historically. And in that model, light can get from the farthest galaxy to the Earth immediately. It takes no time at all. And therefore, there is no distant starlight if you understand physics.
And we have already seen that it isn't entirely consistent with more fundamental physics, which explicitly treats the speed of light as a constant, as both observation and mathematical derivation tell us, and that its constancy is a restriction, so to speak, given by spacetime, and doesn't actually have anything to do with the electromagnetic radiation itself, save for the fact that photons happen to be massless. I think it's also worth noting that, again, Dr. Lisle has appealed to Einstein. Keep this in mind, as it will be important toward the end of this video. But I would like to add that Einstein did not use an anisotropic synchrony convention, and was firmly of the position that the speed of light was constant, which is one of the two main postulates of special relativity. I think it's also worth noting that Einstein, in fact, working with Henri Poincaré, who was a French mathematician and physicist, developed the Einstein-Poincaré convention, which is what most physicists would use, and it states that regardless of the direction of travel, the speed of light remains constant.
And going back to your debate 2 months ago with you, Ross, he objected that your distant starlight argument by asking, when we look at the sun, do we see the sun as it is now or as it was 8 minutes ago? Right. So it appeared that by asking that question, Hugh Ross didn't fully understand the physics of Einstein. Now, what would be the best response or argument to that specifically?
Yeah. When he asks, is it this or that? It's like asking, is a table 3 feet long or is it 1 yard long? And of course, the answer is both. It depends on what units you choose to make the measurement with. And so whenever anybody asks that question, does it take light 8 minutes to get from the sun to the earth, or does it get here instantaneously, or 16 minutes? And the answer is it depends on the synchrony convention that you choose. There is no objective answer to that question. People get frustrated because most of us have a view of time that it's sort of absolute and universal. It's the same everywhere. Clocks all tick at the same rate. Everything, you don't have to worry about these synchrony problems. But Einstein discovered that is not the case. Time is not the universal objective thing we think it is. It's affected by motion, gravity, and things like that. And so the amount of time it takes light, to get from A to B and back to A, that's objective, and that time is objective. And there's no getting around that. The round trip speed of light is set by God in vacuum. You can't change it. But the one-way speed depends on how you choose to synchronize clocks. And so does light take 8 minutes to get from the sun to the earth, or does it take no time at all? The answer is yes. And the same is true for distant stars. Does it take years for their light to get here, or does it arrive here instantaneously? The answer is yes. It depends on which synchrony convention you use.
I just wanted to clip this part out so that everybody can see that Dr. Jason Lisle is openly admitting that any synchrony convention, including his own, is going to be subjective, and that it's like asking the difference between measuring something to be 3 feet long or 1 yard long. It's somewhat similar to how I explained it earlier. And as I said earlier, this depends on the units, as Dr. Lisle has confirmed here as well. Also, as I said earlier, this doesn't change the physical dimensionality of the object being measured, a point which Dr. Lisle seems to be insinuating here. So it seems that he agrees with me that using a different synchrony convention only changes how you measure the speed of light, but it doesn't change what the speed of light is, or the fact that it's constant. Also, I'd like to take a few moments to explain an issue I see with this entire one-way versus two-way speed of light contention. Honestly, I just think that this is obfuscation, and the reason for that is I think that creationists like Dr. Lisle are trying to implant this idea that since light, in terms of at least measuring physical distance traveled over time, cannot be measured objectively in one linear direction, that therefore it can't be established that the speed of light is truly constant in all directions. It may be constant two-way, but not one-way, since we can't measure that. Not objectively, anyway. But remember, the constancy of the speed of light can be determined via mathematical equations, describing the structure of electromagnetic fields in the vacuum of spacetime. C equals the square root of 1 over epsilon naught mu naught. So we don't need to physically measure the distance traveled over time in a one-way direction, or any other direction for that matter, to establish the constancy of the speed of light. Dr. Jason Lisle, who possesses a PhD in astrophysics from the University of Colorado at Boulder, either doesn't know this, which I would find to be a little strange, or he's too dishonest to share this information, knowing that it would invalidate his argument. So we can see that trying to draw some distinction in the speed of light between a one-way travel from a point A to a point B and a two-way travel from a point A to a point B and back to point A seems to be more an attempt to muddy the waters around how the constancy of the speed of light is determined and established. Observations concerning the physical distance traveled over time simply comport with these more fundamental mathematical derivations. And so we can see this obfuscatory nature of the distinction that Dr. Lisle is making here between the one-way and two-way speed of light. It's not a relevant point to make. It seems to be made more so to make unclear our ability to determine that the speed of light is indeed constant.
How do you feel the critics have responded to your arguments overall, Dr. Lisle, on distant starlight in a young universe? For example, as you're covering here, the one-way speed of light and synchrony conventions. In other words, have they provided any sufficient rebuttals? And if possible, and you did cover a couple here, what are the best possible responses to those rebuttals?
I haven't seen any serious rebuttals, to be honest with you.
Well, I believe I've provided a very reasoned and very serious rebuttal to your claims here, Dr. Lisle, and presuming that Standing for Truth will see this response, I would be willing to have a moderated discussion with you concerning this distant starlight problem and your anisotropic synchrony convention as a proposed solution to it on his channel, if you'd both be willing.
People who are physicists and are trained in relativity have, some of them have said, well, Lisle's right about that. So, and of course, some of the papers that promote an ask type model, like the one by Sarkar and Stachel that I like to point out, and the authors are not creationists, but they agree that light can get here instantaneously using the correct synchrony convention.
Well, Dr. Lisle, your anisotropic synchrony convention is not proved. Physicists merely agree that it is a convention which one can use, but it doesn't serve modern physics well because, well, modern physics, from relativistic mechanics to quantum mechanics to gauge field theory, utilizes the speed of light as being a constant, which helps us to relate many facets of physical reality to each other. I'd say I think I've thus far provided a substantive response utilizing physics in the understanding currently held by the consensus of relevant experts, your supposed colleagues, and I still have a final response to your anisotropic synchrony convention after I finished responding to your direct claims made in this video. Physicists don't use an anisotropic synchrony convention. It's not likely they ever will because, to reiterate for a third time, the constancy of the speed of light can be derived via mathematical equations. We don't need to rely on pure physical observations of distance traveled over time.
For the sake of argument, let's accept that your claim for the round-trip average speed of light is 186,000 miles per second. If this is true, and this is the one-way speed of light, then in order to accommodate a 6,000-year time frame, these specific critics have stated that there is simply no reason to think that the one-way speed of light is over 700 times faster than the round-trip speed of light.
Well, when people state things that way, that suggests to me that they're not understanding the physics of the situation. It'd be a little bit like saying the metric system is clearly the correct way to measure things and not the English system of feet and inches. I mean, because 12 inches in a foot, I mean, that seems unlikely. Whereas meters, it's 10 centimeters, 100 centimeters in a meter and so on. That's all 10. That's nice and neat. Nature clearly prefers metric over English. Well, no, it doesn't, because you see, when it comes to a convention of measurement, you can't use Occam's razors. Well, it's more likely to be this than that. No, it isn't. It's your choice. The English system, in terms of inches and feet and foot pounds and so on, it is a lot more complicated. It's hard to keep track of than the metric system. It is. That's why scientists, we like metric. And we do all our calculations in metric. And then if we need to convert at the end, we can. But that doesn't mean that English units are wrong. And it's the same way with the one-way speed of light. It's not that it's this or that or the other. It's what you choose it to be. And that will tell you how to synchronize two clocks that are separated by distance.
Again, we see Dr. Lisle admitting that his synchrony convention is merely that, a convention. It isn't objective. And whilst it may not treat the speed of light as a constant, it doesn't change the fact that it is constant. He also lays out the reason why physicists do not, and likely never will, adhere to something like his anisotropic synchrony convention, because, much like the imperial system over the standard, or metric system, it's much more complicated and much more difficult to work with. He's correct in that nature doesn't prefer metric. We do. But it's also true that a transformation between conventions of measurement doesn't change the physical parameters being measured. A table's length is fixed, whether you measure it in inches or centimeters, even though it would be more centimeters long than inches. The speed of light is not conventional. The method of measurement is. And now that we've exhausted Dr. Lisle's comments that I feel are worth responding to, I'd like to explain the fallacious reasoning behind Dr. Lisle's anisotropic synchrony convention and present what I would say is a knockdown argument against it, given that this reveals the underlying fallacious reasoning, and as everyone should know, a fallacious argument is intrinsically invalid. Dr. Lisle's argument is essentially that because of time dilation effects in space-time, given by special relativity, if you move any two clocks, you will change the rate at which they tick as a result of putting them under motion, and thus they will lose any synchronization between them, even if it's only extremely minute. This is why we must send a photon or a ray of light from one clock to the other and then back in order to get accurate measurements, because it's only that one clock that can be synchronized. And this is how we can get the accurate measurements of the speed of light. And this is sort of a two-way measurement from point A to point B and then back to point A. Thusly, you cannot determine what the speed of light is one way because of that variance as a result of time dilation. You would need to develop some sort of convention that helps you synchronize your clocks to get a measurement. And the two-way can show us that the speed of light, it may be constant, but we can't determine that it's constant when it's traveling one way. As Lisle has alluded to in the video, and the importance of me mentioning his consistent reference to Einstein's authority, his argument rests upon the truth of special relativity and the idea that movement will change the rate at which a clock for any reference frame will tick, which is correct. Time dilation. However, Einstein's special theory of relativity is grounded in two fundamental postulates. Number one, that the laws of physics are invariant in all inertial frames of reference, or frames of reference which can be treated at rest, and that the speed of light is constant in all frames of reference. This means that the argument Dr. Lisle makes, that because of relativistic effects in spacetime resulting from motion and time dilation, you cannot synchronize two clocks and thereby cannot measure the one-way speed of light, and thereby cannot determine that the speed of light is truly constant in all directions, rests on the very truth of special relativity via appeals to the relativity of motion and time dilation effects given by special relativity. This means that in order to argue that the speed of light is not a constant, Dr. Lisle must presume special relativity, which contains as a fundamental postulate that the speed of light is constant. He must presume the truth of a postulate in order to argue to the falsity of that same exact postulate. This is known as a reductio ad absurdum fallacy, an argument which reduces itself to absurdity by presuming its own falsity. And so, we can see the utter ridiculousness, or logical absurdity, rather, of the anisotropic synchrony convention, and thus we can establish that young Earth creationists, like Dr. Jason Lisle, have not come close to overcoming the distant starlight problem. If you're going to go against what observations tell us, you'd better have superior observations and superior theory as well to substantiate your contention. Otherwise, you'll be left in the dust.